Okay, so we are doing implicit differentiation. So hopefully you did the warm up a little bit and understood it. So here is a question. So from the warm up, let's see if you guys could figure this out. So I'm going to write a problem, and what I want you to do is pause the video and see if you guys could do it on your own. So I'm taking y squared is equal to x, and I want you to take the derivative with respect to x. So that means I want you to find dy with respect to x dx. So that's what we're doing. Now, here's the issue. If you're doing it, notice how we have now a y squared, not just a y. So what are you going to do? And what you're going to have to do is the chain rule. So now when I do the chain rule, I am going to take 2, and then I am going to, that's the derivative of the outside, and I'm leaving the inside alone. Please remember, you are going to have, this is what we really have. You have the outside function, which is the square, and you have the inside function, which is the y. So you're taking the derivative of the outside, you're leaving the inside alone, and then you're chaining on the derivative of the inside, which is your dy dx. And then you're taking the derivative of x with respect to x. Well, x and x, it's just one-on-one thing. That's all you're doing. X is changing the way x is changing. We want to know here how y is changing. Right up here, we want to know how y is changing as x is changing. On this side, we want to know how x is changing as x is changing. So what we're really finding there is, how is x changing with respect to x? Well, it's the same thing. So that's why when we take the derivative of x with respect to x, is that you're still doing the derivative of the chain rule. This is 1, but the derivative of the x is dx over dx, which is just 1. They're changing the same way. So this one here is just going to be 1. There is no dy dx or anything like that. And the main thing you have to remember is, if the denominator on this case here is the same variable as that, you take the derivative the way we normally have done it all along. So this is the derivative of x. This one here, because this is y and not x, we have to do the chain rule, and you have to take the derivative of the outside, leave the inside alone, and then take the derivative of that. So that's saying, how is y changing as x is changing? Okay, so now what do we do next? We can't leave it like that. It has to be dy dx equals. We want to know the derivative, and I want something after that. So that means that we have to get the dy dx by itself. So the way that you do that is going to be dy dx is going to be 1 over 2 over y. And so that is what we get there. But we know that y squared is equal to x. So what we know here is that y is actually equal to, if I were to solve for it, plus or minus the square root of x. And so what you get here is that you get the dy dx. If I replace it with what y is, we get that y is equal to dy dx is equal to 1 over 2 square root of x. And you have dy dx is equal to 1 over 2 square root of x, but the negative. So here's what you need to notice, that this y is what this y is after I solved it from there. So I solved it and I got this. So I replaced this y with that, and I got the square root, the positive one, and then this one here is the negative one. And if you guys remember what I told you from earlier in the semester or the first semester, is that when the y is squared, it does not form a function. So here is what is in your booklet on there. We know that, and this is the information that I just said on here, is that we're going to get, when you do it, you're going to get a sideways parabola. Here is your sideways parabola. And the top half is the positive of, when you actually solve for it, you get the positive square root of x, and the bottom half is the negative square root of x. And if I were to take the derivative of each one of these individually, I get 1 over the square root of x, and then this one here is negative 1 over 2 square root of x, and this is what I get. But if you remember, that's exactly what I got right here. Notice how I got the same exact thing on here, 1 over 2 square root of x and negative 1 over 2 square root of x. Now, would it have been easier to take the square root of x and then take the derivative with respect to x without having the y squared? Sure, in this problem, it would be easier. But the problem is that they're not going to be that easy. And sometimes it's not possible to get x by itself. So here it's just showing you that if the operation is happening on the y, or if it doesn't even have an x, everything is done with respect to time, as we're going to do eventually. You don't have a choice. You're going to need to know how to do implicit differentiation, and that's what you get. And so now what you need to also understand is that before we were only depending on the x, and we really didn't care about the y. In this case here, because now the y is being squared, we care on both of them. So this one here gives me a point here and a point here. Now I have two tangent lines. So this is a sideways parabola. This gives me two tangent lines. If it's a function, and this is not a function, if it's any type of function on there, we're only going to get one tangent line for each specific point. For each x value, we're only going to get one tangent line. Now, since it's no longer a function, and it doesn't have to be a function, each x value could have more than one answer on there. So it doesn't have to be a function. So notice how at 4, I have a tangent line here, but at 4, I also have a tangent line here. This is a negative slope, hence this negative, and this is a positive slope, hence that being positive. So now it's just getting a little trickier, and now we know that we don't longer have to deal with functions, and it doesn't have to be a function. Now we are just going to have variables like y and not f of x or s of t or whatever functions we were using. Okay, so let's try a problem. So let's try this one right here. How would I actually solve d over dx dy x? So if you didn't, and if you don't know the other derivative rules, they're not going to go away. Make sure you go back and watch those videos, and make sure you know how to do every single one of those problems. So here, if you look at it, I am trying to take the derivative of x and y. Now here, I didn't say it, but what really is x times y. So I cannot take the derivative of x and then take the derivative of y because they're being multiplied. This means that we have to do the product rule. And so the product rule is that I have to take the derivative of the first one and then leave the second one alone, take the derivative of the second one, leave the first one alone, and then add them. So what you're going to do is take the derivative function, and let me do that with blue on there. Let me see. Let's make that thinner. Okay, so we're going to take the derivative of the first one. So that means we're going to, the derivative of x is 1. We leave y by itself, and then we add. Now we're going to leave the x by itself, and we are going to multiply the derivative of y. The derivative of y, because it's the derivative of dx, I know it has to be dy dx there. And so it's not an equation, so it's not equal to y or whatever. So here eventually we would solve for dy dx. In this case we are not. I just wanted to show you that that's how you would do the product rule. Eventually we'd have to solve for dy dx. So if it's something like 2 here, where we have the x squared plus y squared equals to 4, here you would have to take you do have to solve for dy dx because it's an equation, not an expression like it was at 1. This is an expression, this is an equation. But we know from our projects that we've done in class that this is an equation of a circle. So it's going to be a circle, and it has a radius of 2. So I know it's going to be here, 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 and there. So I know that I am going to have this circle. It's going to go all the way around there. And so when I do this circle, and it's the radius, I know it's not a function. And so I still need to take the derivative of this. So when it says differentiate, that also means to just take the derivative of it. So what's it going to happen? So if I choose anything on here, and if you notice what's going to happen before I actually differentiate, if I take a point right there, notice how it's going to be shared with this point down here. This one's going to be a positive tangent line, so that's going going to give me a positive. This one's going to be a negative tangent line. Notice how here the x value is positive, the y value is positive, but the tangent is going to be negative. The tangent line has a negative slope, so we're going to have a negative. Notice here this the x is positive, the y is negative, and this one here is going to be a positive slope. So this one here is going to be a positive slope, a negative slope. Here, when we do the same thing on this side, this one here is going to be positive. This one here is going to be negative. Now, this one here gives me a positive slope for the tangent line. And then that same point on this side over here, if I do the tangent line there, this one here is going to be negative, and this one here is going to be negative. And if I look at that, that is a negative slope. Are you going to have to remember that? No. The main thing you have to remember about this is that the x and y now matter on what kind of slope you're going to get. Now, let me show you how this is actually going to apply here. So what we do is we take the derivative here, and we're going to take the derivative of this one here, and we're taking the derivative with respect to x. So we are going to try to find that's too thick. We are going to do the dy and dx. So we're taking the derivative. Right now, we're always going to take the derivative with respect to x until you're told otherwise. So right now, we're going to take the derivative with respect to x. So we're going to take this derivative here, and we're going to get 2x and then 1 on there. And then this one here is going to be, again, this is a y, not an x. So it's going to be 2. And then we leave the inside alone, y. And then I take the derivative of y, and I get dy dx. Chain down with the multiplication. And then here the derivative of 4 is a constant. So any constant we know is automatically going to be 0. Now, because this is an equation, we do have to solve for the derivative. We need to have dy dx equals. So that means I am going to take the 2y dy dx, and it's going to move over, and I am going to get negative 2y. And then I'm sorry, 2x, because we're moving the 2x there. And then we're going to have dy dx is going to be negative 2x over 2y. Those cancel, and so the derivative is actually going to be x, y, and then the opposite of the ratio. Notice how the derivative has the x and the y on there. So if we were to make a table, like what does your answer in 2b mean? This means what we were talking about, that when I take the differentiation, the derivative is always going to be the opposite. So the x and the y are going to matter, not just like the x we used to be. So now let's say that I have Q1, Q2, Q3, those are the quadrants. Q4, that is the quadrants there. And we have X and Y, what they are in each quadrant. And then we have the derivative, this part right here, the dy dx, which is the negative x and y, so the negative x over y now. What's going to happen is that in the first quadrant, x is positive and the y is positive, but the tangent, if it's positive and positive, we take the negative out there. And we said that that was going to be negative, and that's what we got right here. That's where we got that negative right there. So that's where you see that negative there. And then we're going to do this one here in the quadrant 2. We know that in quadrant 2, x is negative, y is positive, and we got that to be a positive on there. So this is going to give us a negative, and that's the opposite. So that gives us a positive there. And then they're both going to be negative there. And so that's supposed to be a positive, but because it's the opposite there, we know that that one there is going to be a negative. And then this one here is going to be in the fourth quadrant. We know that that's going to be positive, negative, and so therefore this is positive because we take the opposite on there. And so that's exactly what it means on there, that this tangent is going to be those values that we said that they're going to be right there. Okay, so How do I differentiate? Notice how these equations that we're getting, they're no longer functions and they're getting a little bit tough. You need to know your differentiating rules. This is the one we just did with the x and y, and we need to actually take the derivative of that. It's going to be a little bit more complicated. And then we need to talk about what does it mean for a horizontal and a tangent line there. So here is what the differentiation is. So when I take the derivative of this one here, I'm going to do this in green. Okay, so this one here, I take the derivative of this. And so that's going to be the chain rule. And so I get 3, and I get the y by itself. I just leave the inside alone, and I get that to be squared. And then I have to take the derivative of the inside. So that's going to give me dy dx. Because we're taking, remember, everything right now is going to be in respect to dy dx. We're going to take everything with respect to x. Okay, now the second part, that is going to be, if we notice, it's a product, so we're going to have to do the product rule. But we already did it earlier up here. See how we got that? That is my product rule right there. So what we're going to do is you're going to take minus what we just did. And what we have there is going to be y plus x dy dx, because we already did it. And then the derivative of -6 is just going to be 0. Now, it's an equation, so we have to get the dy dx. This is where your algebra skills have to be good. So we need to get the dy dx here. So I need to somehow factor it out, get it by itself, get it to one side. There are 2 of them. So what I want to do is get rid of the y over on the other side. So I'm going to have this dy dx and then minus y minus x dy dx is equal to 0. So all I did was take the minus on there. I distributed the negative to both sides on there. And then what I am going to do is I'm going to like erase it right here. And then erase that, make that a minus. And then I am going to, because I want to save some room on there, I am going to then move this over. And so I am going to get this, and then that's going to, and I'm going to move over this over here. And so that's going to be a positive y. So you distribute the negative, and then this is the only thing you're going to get. The y goes to the other side. Very good. Okay, so now if you notice, these two have something in common. So that was my goal, is to try to get, then I could factor it out. And so then I get this, and so I get 3y squared minus x is equal to y. And then in order to get dy dx by itself, that means I am going to move this over. Dy dx is equal to y over dy squared minus x, and that is my derivative. So when it says differentiate, is to find the derivative. We did. We got the dy dx. Notice how there's only one dy dx, nothing else there. And so then we are done with that. So part B, it says find all points where the tangent line to the equation we just differentiated is either horizontal or vertical. Now, anytime you see tangent line, that is going to be the tangent lines to that equation. So we want to know where they're going to be horizontal or vertical. One of the things that you need to know is that when we're talking about tangent lines, we're talking about slope. So we're looking at slope. So when anytime we have the slope to be horizontal, that the line is going to be, the tangent line is going to be horizontal, that means that the slope is going to equal to 0. So I know that slope is the change in y over the change in x. So once I know that, then what we do is, in order for the slope to be 0, that means that there has to be some value of x in the denominator, and the numerator has to be 0. Because if it's not that, then it's going to be undefined. It doesn't matter what x is, any number, as long as it's not 0, the numerator has to be 0 for me to have the slope of 0. So that's what it means for the horizontal line. For the vertical line, vertical lines do not have slopes. They're undefined. So that means that the slope of a vertical line has to be undefined. And so in order for us to do that, if I have the change in y over the change in x, that means that I could have a number, any number for y, and I'm going to have 0 in the denominator. So that means that I am going to have 0 in the denominator, and that is going to give me the vertical line. So we want to find all points where the tangent line is either horizontal or vertical. So this is what I'm looking for. If I want the horizontal line to be that, that means that for the horizontal line, that means that the numerator has to equal to 0. And if I want the vertical, that means that the denominator, um, that the denominator, I'm sorry, denominator has to equal to 0. I don't even know what I'm writing. There we go. The denominator has to equal to 0. And so we have the derivative already down here. So when we want the numerator to equal to 0, that's what we're going to do. So in order for us to have the numerator to 0 for the horizontal line, and I'm just going to do horizontal line in yellow, so the horizontal line, that means we're going to have y is equal to 0 because that's the numerator right there. Y is equal to 0. We're setting the numerator equal to 0, and so we get that y is equal to 0. So when we put that, we're going to put that back into our actual because we want to know the points on there. So that's the point that y is equal to 0. Now I have to go back into my equation, the original equation, because that's the one that we're talking about, and we get 0 cubed minus x, and then 0 is equal to negative 6. Well, it turns out that 0 is equal to negative 6. That is not true. So that means that we only have a y0 but no x, so therefore there is no point there because a point has to have an x and a y. Therefore, there are no horizontal lines. Okay, so there are no horizontal tangent lines. So then we are done with that part right there. Okay, so now what happens for the vertical line? So that means now that we have to set for the vertical, we have to, for the vertical, we have to set the denominator, y squared minus x equal to 0, and we have to solve it. So when you solve it, you're going to get, now notice how you have a y and you have an x. So you're going to get this by itself. So I'm going to get a negative x is equal to 3y squared negative. So x is equal to 3y squared. And then I need to get this over. So it's going to be x over 3. It's going to be y squared. And then I am going to take the square root of both sides. And so and you actually don't even need to go that far. You just need to know not even that far. We could just go here. That's what x is equal. We don't always have to solve for y. We could actually just solve for one, the x or the y. Here it's much easier. It's going to get a lot of more algebra if we go on and solve for the y as I was doing. We could stop right there because you're not going to get a nice answer like y is equal to 0 on here. We just know that x is going to equal to that. So we're going to go back to the original function. And so we're going to put that back in there. So we're going to go back to the original function, which is going to give us y cubed minus, and instead of the x, I'm going to replace it to 3y squared, and then y is equal to negative 6. It's almost like, remember when you guys did the system of equations? I got 2 equations and I have 2 unknowns and I need to get 1. So I need to find out what one value equals, whether it's the x or the y, and then I could substitute it back in to the other equation or the same equation and get the actual value back. So here I know what x equals. I go back to the original function, I replace the x, and now if you notice, they're all in terms of y. So now I just have to solve for y. And so we get y cubed minus 3y cubed minus equals negative 6. And so then here I end up with negative 2y cubed equals to negative 6. And so we get equals to 3. Because it's going to be positive, and the cube root, I'm going to take the cube root, so it's going to be the cube root of 3. And so that's what we end up getting on there. And then we could go back and substitute that back into the equations for both of these. So we are going to end up getting, if we look at that, you're going to get the cube root of 3 cubed, because that's what y equals. I don't know what x is, and then I'm going to replace the y here, and equals to negative 6, because I know what y is now. I need to know what x is, and then once we put it in our calculator, it turns out that x is approximately 6.240. So the answer that we have here is at 6.240, and this one here is approximately 1.442, that this one here is going to be 1.442. So at this point right here, this one here is going to have, because the question was, find all points where we're going to have a vertical tangent line. And this is the point where we are going to have a vertical tangent line. And there you go.